This video, we're going to find the vertex of the quadratic equation and then determine whether the graph opens up or down by inspecting whether A is positive or negative, and that's going to tell us whether the vertex represents a minimum or a maximum on the graph. So if the graph opens upward, the vertex is a minimum. And if the graph opens downward, the vertex is a maximum. So we're not going to ask if it's a minimum or a maximum right now, but that's why we're interested in this, about knowing whether it opens up or down, to know whether that comes to a low point or a high point. So we have f of x is equal to negative 25x squared plus 10x plus 8. And so we can take our pick of how we want to find the vertex. Nothing says that we have to answer these questions by writing it in vertex form and then finding the vertex. So we're just going to use the formula method, that we've got negative b over 2a is negative 10 over negative 50 is 1/5. And then really wish we had for sure done synthetic division at this point. So I'm going to show it to you anyways. Just going to show you this technique to evaluate a function, that if I have all the powers represented, I can just write down the coefficients here. You'll definitely learn about this in pre-calculus. I'm going to write down the 1/5 here. Negative 25 times 1/5 is a negative 5. And then that's 5. 5 times 1/5 is 1. And the answer is 9 for what f of 1/5 is. So that means that my vertex is at 1/5, comma 9. And my parabola has a negative leading coefficient. Since a equals negative 25 is less than 0, it's a negative number, the parabola opens down. If you don't know this technique called synthetic division, don't worry about it a whole lot right now. We'll explain what it has to do with long division later. But right now I'm going to use it to evaluate these functions, just because it's the easiest way to find the y component of the vertex for me. Okay. Our next problem is negative 16x squared plus 24x minus 5. So negative b over 2a is 24 over 32 is 3/4. So I'm going to put 3/4 on the outside. Negative 16, 24, negative 5. Negative 16 divided by 4 is negative 4. Negative 4 times 3 is negative 12. 4 goes into 12 3 times. 3 times 3 is 9. 9 minus 5 is 4. So my vertex is at 3/4, 4. And we open down because a is negative. Since it opens down, that means that that vertex represents a local maximum. It's also the absolute maximum of the graph. 25x squared minus 30x plus 8. And negative b over 2a. 30 over 50 is 3/5. 3/5 out here. 25, negative 30, and 8. 25 divided by 5 is 5. 5 times 3 is 15. That's negative 15. Divided by 5 is negative 3 times 3 is negative 9. That's a negative 1. We've got a vertex at 3/5, negative 1, like so. And this one opens up since the leading coefficient here is positive. That means that my vertex is a local minimum, also my absolute minimum. So I think I might have one or two more of those. One more. All right. Negative 25x squared minus 40x minus 7. So we have negative. The opposite of a negative is a positive. 2 times a negative 25 is a negative 50. That gives me a negative 4/5. Negative 4/5 on the outside. Negative 25, negative 40, negative 7. Bring down the negative 25. The fifth of that is negative 5 times a negative 4 is a positive 20. Gives me a negative 20. Divided by 5 is negative 4 times negative 4 is a positive 16. That's a 15. So I have negative 4/5, 15. And then this is going to open down because my leading coefficient here is negative. All right, next time we come back, we're going to look at some equations that are written in vertex form, and we are going to graph them. So get ready for that. We're going to start looking at some of our graphing and analyzing of our graphs in the next couple videos. All right, see you for the next video.